Hey folks, how's everybody doing today? Happy Tuesday, right? No, Thursday. Yeah, it's Thursday. I know what day it is. Alright, let's kill this one here. Alright, I got a couple things today. Thanks for getting your Project 2s in. Don't forget that was due now. So I think we got everybody in. The Chapter 5 and 6 quizzes, I got set due for tonight. If you do need a little bit of extra time, go for it. I know I doubled up on you. That's my fault. So we'll take some extra time on that if you need it, but you definitely want to have it done before the midterm on Monday, right? Because that way I've got a chance to score it, and you can get your answers there and everything that you need. Because again, the midterm has quiz-style questions, so you want to be familiar with those and make sure you feel good about your answers there. So the lab, I've got due next Monday. If you need a little extra time on the functions lab too, because we're not actually doing a lab for strings, that's fine. Maybe I'll push that one out. Actually, let me go do that. We'll make that one do the week after, just in case you need a little extra time. I want to chat about it here. We can focus on the midterm for Monday. We can go from there. Grab 5 here, and we'll edit that due date. All right, let's change that one here. Let's pick on, it'll put us out to the 2nd, right? Come on, Canvas. Work with me here. There we go. Oh, November 1st. That's right. We got 31 days. That'll be the 1st. If you need a little extra time on that, that's no big deal. Okay. Again, so the plan is midterm during lab time. So it is open book, open notes, open internet. You've been allowed to be a remote the whole time. If you're not comfortable coming in person, I get it. We're still in the middle of a global pandemic. No big deal there. So if you want to just take the midterm from wherever you are usually doing labs, that's perfectly fine. Again, I know not everyone necessarily does all that well at 2 in the afternoon. So what I'm proposing to do is I'll just open it up come Monday, and then as long as you get it in before midnight on Monday, you'll be fine. The caveat there being, though, it is timed. So like once you hit start, you'll have 2 hours to hit submit. And I'll bump it out to 2, give you that extra 15 minutes. No big deal there. Right, if you don't want to do it at 2 in the afternoon, that's perfectly fine. If you prefer working in the middle of the night, great. Take it late at night. If you want to even take it in the morning, I can open it up early in the morning if you're a weird morning person, which I guess some people are. I just don't understand that. I much prefer the late hours myself, but that's okay. I know everyone's a little bit different. So no need to come in person to the lab if you don't want to. Again, if you'd like to, great, there will be open and you can use the computers there. Just please use Pycharm for those coding questions, right? Like use your development environment. Don't just pretend like you're coding right into Canvas. That's awful, right? Make sure the code runs and try it, that sort of thing. So I'll open it up early, 10:25, and you'll have till midnight, 10:25 to submit. But once you hit start, you've only got 2 hours to submit it. So just make sure that you are planning accordingly for what time you want to set aside to take that, and we can be flexible there. And then come Tuesday, we'll pick up lists and dictionaries. We'll do the next individual project. That way you don't have anything going on in between now and the midterm. You can just focus on that if you want. We'll pick up project 3, working with lists and dictionaries and strings and functions and things. So we'll do that one for 2 weeks, and we'll have exceptions and modules. We'll do one last individual project on classes, and then the week of files, we'll talk about the final project as well. We want to make sure we've got enough time to work on that one here. And then our final exam slot, I did update this. Apologies for the placeholder in there before. It looks like our final exam slot is 3 to 6 p.m. We'll just meet together on Zoom, and you can present your final projects to the class. Should be interesting. We can talk about them, and we'll have a little bit of fun. So because this week is strings and we have a midterm, I wasn't planning on giving a quiz on strings, if that's all right with you folks, because we've got the test on Monday anyway. So you don't need to kind of double up on strings or anything there. So we'll pick it back up with lists and dictionaries. We'll do a quiz on that, quiz for classes, exception modules, files, and so on and so on, if that sounds all right. Okay, so I'll put an announcement out there. Yeah, just through Chapter 6 functions. Yep. So, I mean, there's a question on strings, but it's not any of this stuff that we've been doing in strings, right? Like if you look at those example questions, it's like grabbing stuff out by index, which we've already done before. This sort of looping through things. We've looped through strings and grabbed them by index. No, nothing super fancy here with our strings in this chapter. So you should be fine. We'll look at those sample questions. Like there's the question on loops. Great. There's a question on functions, and there's a question on, my goodness, on doing something with a string, but not, I don't know, nothing too crazy with it. We'll take a look at that. So we do the midterm review. We got project 3, and we'll go from there. All right, so the first 15 questions are all quiz style questions, including, and then basically a free point here for agreeing to the academic integrity policy. It's open book, open notes, open internet, but you cannot work with people, and you please do not post stuff on Chegg or similar sites and then tell me you cited your source online, right? My goal is to write a question you can't Google, and then if you go post it and be like, oh, look, I Googled it, that's obviously cheating. I feel like that's obvious, but apparently I have to be very explicit here. So again, programmers make lots of money, and no one has ever told them you have to do this by memory. Please don't ever look anything up ever. That's just stupid. So I don't expect you to do that on an exam either. So use your sources, right? Everything we did should be able to find examples from the lecture, from the iBook. You shouldn't have to go down some deep rabbit holes on Stack Overflow or anything for any of these things. We should be in good shape. And then the 14 remaining quiz style questions here. And then we get our long answer question. So the long coding style questions, like write a function, difference of primes and non-primes through n. And I even said, hey, go use this prime example here if you want, right? So you don't need to figure out how to figure out if the number is prime. That's not what I'm checking for. I want to know, can you loop through numbers, use this function, and then give me the difference here. So let me fire up Pycharm, and we can do the midterm review first, and then we can come back and do project 2, and then we can come back and finish up strings. That sound like a good plan? Goodness, I don't know that number. It's probably none of you folks, right? It's a 310 number. It's funny now that like everyone can keep their area code. It used to be like, oh yeah, that's a local number. It might be somebody local, but it doesn't work like that anymore. It's kind of funny. Yeah, 304. I don't know what zip code that is. Look it up. 304 zip code. Or no, area code. Yeah, I can do that. I know the difference between area codes and zip codes. Area code. West Virginia. Okay. I don't know why someone from West Virginia is calling, but that's fine. All right. Again, my goal for these here is that, if these take you 15 minutes per question, that's 45 minutes, and then 2 minutes per short answer style question puts you at an hour 15, and then you've still got some wiggle room in there as well. Not too big of a deal. And then if you need a little longer here, right, even if they take you half an hour per long answer question for these 3, then you just got half an hour left for the short answer question. So you should be in pretty good shape is the goal here, even though it's timed. I know timed exams are awful, but I think it's enough time to get these ones done here. That's the goal. Come on, Pycharm, new project. I think I clicked the button. Apparently I didn't click the button. There it goes. We do midterm review. I'm going to do it in a new window because I'll leave that open to come back for strings in a minute. See if it doesn't slow us down too much. All right. Awesome. So we were going to do a function called difference of primes and non-primes through n given a number. Okay, so we'll define a function given a number. Now, I said go use this function here, right? This will be a little shortcut for you. There we go here. So to figure out whether or not something is prime, here we can just go copy paste that. So we'll need that as another function then. Right, so if it's 2, it's prime. If mod 2 is 0, or it's 1 or less, not prime. But we need math here too, right? Math. And then the square of the number, because if you can't find a divisor up to your square root, you're not going to find one larger than your square root. This is just a shortcut here, shorthand notation. I stole this from online somewhere too. I probably cited it over in here. Yeah, look at that. Oh, that was from last time I stole it from. I wonder where I stole it from there. All right, let me go back and find where I got this from. Let me go all the way back here. Let's see. Oh shoot, I don't even have that listed. I don't remember where I got that one from then. I stole it from somewhere. Sure. Yeah, definitely. We'll do project 2 after this, for sure. Yep. We'll do the midterm review, we'll do project 2, and then we'll finish up strings. So then checking every divisor in range starting at 3, going up to the square, right? The square root as an integer plus 1, like rounds it up 1 essentially. Math.ceil will probably work as well, but this way we have an integer value. And then going by 2, because I don't need to check the even numbers. I've already checked all the even numbers. If we can evenly divide the divisor, we return false. If we've gone through all of them, we've gotten up to the square root, and we've not found a divisor, it is true and it is a prime number. Cool. So if we need a difference of primes and non-primes through n, so I need the primes sum. Or really, actually, we can just keep I don't know, a difference here, right? Start off at 0, and then for, now, our definition here has 1 not being prime, so we're going to say for number in range, I can start at 2, and if it's inclusive of n here, right, through n, including n, right, so when n was 9, we included 9, I need to make sure I'm ranging to number plus 1, because that way I'll stop at number. Right, if I just ranged to number, I'm not including that n value, number value here. So that's important. Make sure we're doing that. So, well, I guess actually we included 1, right? So yeah, 1 was not prime. So I'm going to start at 1. My apologies. We'll start at 1, go up to including number, so 1 plus number. And then if now our is prime function is prime given the number, if it's prime, right, we are adding the value, subtracting the non-primes. So if it's prime, then my difference is going to be plus equal to number. If it's not prime, number, enter. There we go. Else, my difference minus equals the number. So if it is prime, we add it. If it's not prime, we subtract it from this difference, this running difference here. And then we're done, we can return the difference. Okay, that's the whole function. We just, for every number, we got a couple gotchas in here, right? Make sure we're ranging to the right value, inclusive here. And then if it's prime, great, add. If it's different, if it's not prime, subtract. That sort of thing. That makes sense for this one? Cool. All right, the next one then. Write a function bad encryption given some string that returns a list of numbers where each number is the character's Unicode value plus its index position in the string. So bad encryption of some string will print out a list of numbers. And then we're going to write reverse bad encryption given a list that returns the string where each letter is the character value of the number minus its index in the list. Okay, so write a function for bad encryption here. And encryption's a terrible word for this, but it's, sure, it's encoded. I guess it's probably a better word here. It's not true encryption. So to get the Unicode value out, right, that's ordinal. So we're going to say the values is a list here, and then for character in some string, we're going to take the values, and we're going to append the ordinal value of the character. And we can return values. Right, so for every character in that string, for every letter in that string, take the ordinal value, add it in. Oh, but we didn't. Oops, I'm missing my step here, right? Plus its index position in the string. Okay, so we can't use this basic for loop here because I don't have the index values. So we have two options. One is we just use an index. and then we can add the index. That's probably easier. There's also that really cool enumerate function, which gives you the value and the index, but I think this one's easy enough. So we'll say index in range of the length of some string, I need to append the ordinal of the sum string at the index plus the index. Right, ordinal first plus the index. So get the ordinal value of the character at that index. So index 0, 1, 2, as many indexes we have in the length of some string here. Oops, one more closing parenthesis. There we go. And then we'll add the index position. Right, then we can return that values list. Okay, and then our reverse here, our define, what do we call it? Reverse bad encryption, given some list, returns the string value. Here, so we're doing the opposite now. Encryption. Did I spell it wrong? I did. Encryption. There we go. So we're going to do the opposite. So we're going to subtract their index value. So again, so for index in the range of the length of the sum list here, we need a string to be adding onto. So we'll have our word, starts off as nothing, right? So we're going to take word and we're going to add to it the character of sum list at the index plus the index. Oh, I'm sorry, minus the index. Right, so we took the ordinal and we added the index. So we're taking the value minus the index, then turning it back into a character. And we can return the word. We can actually try it out, right? So I think I gave you an example here. So if we gave it midterm, should get those values back out. Let's try it. So we'll have a print bad encryption of midterm, and then we can even save this, right? So our I don't know, value is this. And we can print the value, and then we can print reverse bad encryption given the value. Right? We should get midterm back out if it works. Let's give that a little run. And we probably should have tested our prime and non-prime thing too. But yeah, we get midterm back out. Looks like it works so far. Should we test our, right? Any code that's worth writing is worth testing. So let's try it. So let's print our so difference of primes and non-primes given 9. Right? I said if it was given 9, we should get back out negative 11. Right? Let's see if that works for us here. Okay, negative 11. Cool. I feel pretty good that that was working here. So again, it's kind of using strings, but not really like any interesting string functions or anything like that. It's just essentially the index of a string here is the only thing we did with it for that question. And then the last one, again, this is still not even really doing anything with strings out of that string method here, but it's ensuring none of the letters are in a string, given letters to check for in the string to check. Returns true if none of the letters are in the letters to check. So kind of long here, but it's saying, hey, are there any letters in the string we're supposed to check here? We'll define, ensure none of the letters check are in the string. Okay. So we were going to return true if none of the letters to check for are contained in the string to check. So it's a quick loop here. And otherwise we return false. So we can say for character in letters to check for, if the character is in the string to check, right, we can use that in operator, return false. Capital F false. There we go. Right, so for every character, if that character is in the string, return false. If we've gone through every character in the ones that we're checking for and we haven't returned false, we can return true. Right, I did not find, right, if I didn't return false, none of these letters are in the string we're checking, I can return a true once I've checked every letter. Just a quick little loop. Right, and again, using that in operator versus the in with a for loop here. In is really handy. Does a lot of cool stuff for us here. Sorry. The coffee was chunky at the bottom. That was not a pleasant surprise. Wow. Yum. Okay. And of course, I got the marathon mug. I mean, what good is it running a marathon if you can't brag about it, right? Feels a little silly, but I mean, why not, right? Totally earned that. Totally earned it. So I'm actually feeling better today. My leg's mostly back to 100%, I think, which is pretty cool. So it feels good. All right, so that's it for the midterm review. Any other questions, thoughts, or concerns? Yeah, so you get 3 similar questions. So one on writing a function, probably dealing with prime numbers. Well, Bayman, I didn't run the whole thing. There was a lot of jogging and walking, but I made the distance. Yeah, I completed a marathon, I should say. Yep. So it's my 6th time doing the free press marathon. I've been doing it for a lot of time. No, the ancient Greeks guy could always do it, I thought, right? Yeah, I always liked running. I did cross country briefly, and then track and field. I ran the 2-mile in high school, and I had a lot of fun running. And then I got busy and stopped running for a while in college and started having kids and stuff. But a buddy of mine invited me to run with him in 2014 and was like, hey, you should sign up for the Free Press Marathon. It's a lot of fun. I'll run it with you. And I was like, okay, sure. So I signed up, and he didn't sign up, and then they ran out of spots by the time he tried to sign up. But it was okay. So I ran it myself, or still, jog and walked that one myself. And I've been doing it every year since 2014. We missed it last year because it was canceled. And 1 year I just didn't do like much training at all. So I decided to do a half instead. He collapsed from exhaustion after running it and died. Now he just run for fun and bragging rights. That's a good fun fact. I thought it was just like the distance between their 2 cities or something. Is how he came up with it. I didn't know there was a guy. But you had to be able to do it to be the messenger, right? To run messages between the cities before they figured out smoke signals or something. Yeah, cool. So let me push this out here in GitHub for our midterm review. So you got all this available to you. Again, hopefully you had a chance to try these before you just watched me solve them, because that's going to be much better practice. So 501, make sure we're in the right repo here. Yep, so your questions will be in the same vein. So one question about a function, probably dealing with prime numbers, right, and some sort of looping. One question about dealing with strings and their positions and ordinal values, right? And then another one dealing with strings and loops and contains, that sort of thing here. So in terms of like the what chapters that stuff comes from, right? You need all of the loops chapters, you need all of the branching chapters here. That sort of thing, but we essentially stop at functions, right? We're doing some cool things with strings, but we're not going to need any of that advanced strings. We're not going to do string slices or anything. Not that you couldn't use it, but it should be pretty good for midterm practice. And then all the quiz style questions then will come out of 1 through 6. So we won't, because we don't have that quiz on 7. So we'll stop at chapters 1 through 6 for the quiz style questions. Okay. Cool. So let me post the midterm review. So if I ask you a question about prime numbers, I'm going to link to that is prime function in the midterm review and say, hey, just go use this one. No big deal. Right. I know people can just Google prime number functions. And so it's actually funny. At one point, I thought it would be a good question to like, hey, write your own is prime function. And the people who did this, I knew cheated versus someone who wrote it themselves. Right? And I totally caught them on it because their code was identical to this version that was online when they did something like this. So I've since learned that I shouldn't give questions that you could Google answers to and just trust you not to Google. So which is unfortunate, but it's what it is. So this part I'll just give you for figuring out a prime number. No big deal. All right, so on to project 2. So let's take a peek here for project 2. I got this one committed. Start up a new project. Project 2. Now, actually, hang on. Let me cancel that. We did the project 2 shell, didn't we? Like, if we looked at what it might look like with functions. Didn't we do that? Like a recent project 2 stub. Yeah, our stub here for project 2. Let me do that. Because we can take advantage of these functions here, which is fun. Which is what we had. All right, so I've got my strings window. I got the 2 stubs. All right. Awesome. Right. So this was essentially what we had, right? A bunch of different things, right? This is what the method might look like here for us to do stuff with it. So for their current age is less than the retirement age, right? After getting their age and retirement age here, do you want to add more money this year? Yes or no? And as long as that's a yes, okay, which one? Which asset type? How much do you want to add? Right? Ask how much to add to the asset type, and then add to the asset type, right? Given all of the different ones, because again, passing the values back and forth can be a little bit funky. There's other ways of doing this, but when we talk about classes, not next week, but the week after, we'll see a much easier way of doing this sort of thing, which is super cool. But for now, I think this will suffice here. So, you know, we just do it all at once then instead of 3 different methods for adding. And then do you want to add more? Again, right, to figure out whether or not we're going to keep on doing this loop here. And then we add the return on the investments, right, for these given values, each one, right, one each year. Banks was a fixed amount, bonds was a random amount, and stocks was a random amount. Take a peek at those. Right, so we said 1% always for bank savings, 1 to 5% randomly for bonds, and -10 to 20 for stocks, because stocks kind of go down, right? That's sort of the idea here. Okay, so we're just going to finish out this stub here then, right? So to get the user's name, we'll, you know, get the name is an input of, what's your name? Your name, human. And then return the name. Great. Okay, get the initial money for an account, given the name of the account here, we'll return a value, and that value then can be stored for these here. Right, so the account type is the name of the account. So then we can get a, I don't know, initial balance is probably an int. I mean, most people probably won't give us pennies. If you did doubles, that's fine too, or floats, that's fine too. Of an input, how much money do you currently have saved in your, probably like a formatted string here, right? I can throw in account type. Okay, and then we can return that initial balance. Right, so the only thing that's different here, right, where we want to not reinvent the wheel, is we say how much money is in your mattress, in your bank, in your bonds and stocks. Right? So maybe save/invested, I don't know. Sure. In your, I don't know. So the grammar here is going to be a little bit funny, but again, we don't care too much. Get current age and retirement age. So we need 2. So we'll have a current age is an int of an input. Input. How old are you? Right? And then we'll have a desired retirement age, or retirement age is an int of an input. What age do you want to retire? And then we can return them both, right? Current age and retirement age. Retirement age. Right? It'll do that automatic packing as a tuple for us, and then we can unpack on the other side. Again, I know it's a little cruel, I'm sorry to be asking you to think about retirement already, but that's sort of how the system works. And when we play with this, hopefully you're going to see that the earlier you start saving money, the better. Right? And then take advantage of the power of compound interest, which is fantastic. We're a big fan of that. We being, I don't know, everybody? I don't know. And do you want to add more money this year, given the current age? So we're going to get a yes or no, right? So that's just I don't know, an answer. Is an input of, do you want to add more money to your accounts at age, current age? Oh, they've got a formatted string. I throw the little f in here. Okay, and then we can return the answer. It's either a yes or a no, so probably, you know, prompt them here like y/n for yes or no. Right, do you want to add more money this year? We were asking them if it's yes or no. And we probably want to lowercase it then too, right? So answer.lower. We can make it lowercase, so that way when we're checking it here, we know we can check against the lowercase version. Or maybe we do it in here. It probably doesn't matter much. How about answer.lower here? No, we don't have to do it here. Okay, and then what asset type? Right? Sure, so we'll ask them what asset type. So that was mattress, bank, savings, bonds, or stocks. So we'll get a asset type equals nothing to start. And we can do a little validation loop here too, right? We can say, well, the asset type is not in, and if we give a list here of mattress, bank savings, bonds, stocks. Wait, oh, sorry, I'm mixing up my single quotes and double quotes. That's unfortunate. Bad form, bad form. We'll stick to singles. Oh, I should have stuck to doubles. That would have been faster. All right. So if it's not in the list, right, then we can do this, right? We can use this membership operator and say, or not in the list here. We'll ask them, the asset type is equal to an input of what count do you want to add more to? And then like give them the options here, like mattress, bank savings, bonds, stocks. Bonds or stocks, I guess. And as long as it's not that, then we're going to keep on asking them. We're going to keep on asking them, and then we can return that asset type, right? This is an advantage. We can do this sort of validation here pretty easily, right? How much money do you want to add to a given asset type? So a money to add, we'll ask probably an int of an input. How much, or a formatted string, right? How much money did you want to add to your asset type? Okay, and we can return the money to add. Okay, then this add to asset type is a little bit funny because, right, we need to give them the different options because I don't know which one it is yet, so this one has to do that checking. So we can say if the asset type is equal to mattress, right, because we said mattress was the valid type here, mattress, then we're going to take the mattress money and we're going to add the how much to add. Okay, if it wasn't that, then else if the asset type is equal to bank savings, right, just like we did in our validation here, right, then we'll take the bank savings, we'll add the how much to add, plus equals how much to add. Right, if it wasn't that, else if it was the, oops, that's double equal sign here, right, it's yelling at me there. If it equals bonds, then we'll take our bond savings, we'll add the how much to add. Else if it was stocks, and again, this might be an else here, like if you could just default it there, but I think this might be safer just in case we didn't do this sort of validation loop here, right? Just leave it as an else if. We'll take our stocks, we'll add the how much to add, plus equals the how much to add. And then when we're done, we need to return the mattress money, the bank savings, the bonds, and the stocks. Right, return those four values, and we're going to unpack them here, right? This was add asset type, right? And we return those four values, so we're updating them. Okay. Oh, sorry. Pennsylvania number. Now, I don't know why people are calling me all of a sudden. That's funny. That's weird. Let's see. I don't think they left a message. All right. Sorry about that. Okay, so then ask what asset and how much to add. Oh, did we do that different? No, we decided not to use that one, right? I guess we could have done that as one, right? Instead of three different methods, right? We could have just done them all as one. Okay, that was my comment here. Those three steps could have been one method, essentially. Sure, why not? But we could do it this way too. Right, as three different ones. There's no wrong way, right? Essentially, they're just different approaches. No big deal. Right, and then do you want to add more money this year? We have already, right? We did that one. If it's a yes, and then, so we don't actually need to write this one because we just commented that one out. So I'll just leave that there. And then add return on investment. Okay, so our bank savings was going to plus equal the bank savings times 0.01, add 1%. The bond savings, we need a random value here, so we need to import random. Right? Now we can get that random value, so we're going to add our bond savings times random.rand int, and we said we wanted from, what do we say, 1 to 5%, right? 1 to 5%, okay? So we'll do 1 to 5, and this is inclusive, but we need that divided by 100. Right? Because I will add 1 to 5%, right? In either direction, right, the math should work out the same, right? We're going to add that to our bonds, and then the stocks here then. Stocks will plus equals my stocks value times, and we get a random rand int, and we want it -10 to +20 divided by 100. So if it's a negative value, and when we add negative, it's subtracting, right? We can return the bank savings, the bonds, savings, and the stocks. Okay, so we'll return those three things. Add the return on investment, save them back here. Okay, calculate present value. So given the age, retirement age, and the total value here, so we're going to return, this is just one little formula here, right? It's going to be the total value divided by 1.03 to the power of retirement age minus age. Right, so for every year, if we are assuming a 3% inflation rate, which again, you know, I know it changes and it goes up and down, but we got to pick something here. Right? Every year our money's worth 3% less. Sure, we can then divide our total value and return that. Kind of all in one line if you want. If you want to do it in 2 lines, that's great too. And I think that's it. So should we try it? Let's try it. Okay, so what's your name? Eric. Oh, we didn't use the name in the rest of the prompts, did we? Get their name. So to use it in all the prompts, that was my mistake here. We would have needed to pass name to all of these. Right? Name would have had to have been passed into each of these. We could do that here, but for now, can we just pretend we skipped that, or are you going to feel too bad? Did I not attach a rubric here? I thought we had a rubric for this. Did I not give you one? I'm so sorry. I really thought I had a rubric in here. What happened to my rubric? We don't have one. I'm so sorry, friends. We definitely should have had a rubric there. That's my fault. Can I just go back twice? Wow. Okay. I'm feeling really bad now. So I just skipped it, so I'm going to ignore that, right? So let's do the rubric now then, right? This is project 2. All right, so for the first one here then, ask for name, sure. Doesn't need to use it ever again. That's my mistake here. So you get a point for doing that. Okay, because I totally forgot, and it wasn't in our stub, so that's okay. Gets the initial values. Gets initial values. I don't know why there's an apostrophe there. That is improper. You can get a point for doing that. Right, because that was all basically, we did that already here. Now then our loop is the more interesting thing. Oh no, all right, getting age and retirement age, sure. Getting age and retirement age. These are like free points, right? Because we did this in version 1 of the project here. So I don't want to give lots of points for those. All right, and then here we go. So for every year until retirement. So for every year until retirement, you can allow user to add more to any account. So first, we'll ask user if they want to add more. User, if they want to add more. Let's do, we'll do 2 points for that one. Why not? Right, and then this continues until they don't. Right, that's really a 2-part there, right? So you keep on looping until they don't. And then for every year until retirement, allows user to add more to any account. Do 2 points for that one. Okay, and then for every year adds return on investment for bank savings, bonds, 1 to 5 random, stocks -10 to 20 random. Right, that's 3 different things there, so let's do 3 different points for that one. How does that sound? Right? Our increases. You know, let's bump that up a little bit here. Let's make this one 3. I gotta add a couple more points here. 3. Make this one worth 5. Sure. And then at retirement age, displays value and current value adjusted future value. I forget what I call it. Future value adjusted for inflation. We'll do 1 point for that. Any objections, or does this sound fair? I apologize. Again, I should have had this in for you sooner. Sorry you didn't have this to know, but should go off of everything we asked for in here. Exactly, right? So no big deal there. And then use that rubric for grading, create the rubric. I'm so sorry I didn't have that in earlier. Like this was the big one, like looping through every year. This was the big portion of it here, working with our loops. So most of the points come from that. A couple freebies here, and then this is essentially the same thing too. So a couple free points from project 1, modifying it to do the loops here was the bulk of it. So hopefully that sounds fair. I apologize for that. But let's try it, right? Let's run our sub. Okay, so how much money do we currently have under the mattress? Let's put $100 in each. 100, 100, 100, and 100. Okay, and we'll say if we're age 20 and we retire at age 70, and we'll just say no for every... Oh, uh-oh. Our age isn't going up. Uh-oh. We did a while loop. Right? Uh-oh. All right, well, we got to stop that. That's an infinite loop here. Right? Make sure current age goes up 1 inside that while loop. Right? Current age plus equal 1. Right? Make sure we are increasing our age. Or we could have done like a for loop with the range, but this should be fine too. Okay. Eric, 100, 100, 100, 100. Well, let's say we're 20, retire at 70. So no. No, 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 no. A bunch of no's here. And actually, anything other than a yes, it should just not take. So I could just enter too. I don't think I need the no's. Uh-oh, value at retirement age. Oh, I didn't actually print it, right? So I have to print that value. So print total value. Total value. Retirement age, total value, and print, even a formatted string, value in today's dollars, days, dollars, present value. Sure, I should just do a double quote string there. Let's do it the easy way, right? All right, one more time. Apologies. We'll get this to run. So it didn't quite have everything out in the stub done, but that's okay. 100 in each. 20 and 70, and I should just be able to hit enter. Yep, I don't even have to give it anything, because anything other than a yes here, which an empty string is not a yes. You just enter on through here. Boom, boom, boom. So total value went up to 922. Cool. But only worth 210 in today's dollars. So not a huge gain. I mean, we doubled, but not for a huge factor. And maybe we do these cool like 0.2fs here to round some of those values out, because the math there's got a little funny here. So maybe do some rounding here. Sure. Okay, let's do this again. And let's just look at this here. I will say Eric, and we'll say we got $100 in each. And if we're at age 20 and we want to retire at age 70, let's add more money each year to stocks. We'll just add $100 each year. So no more, yes, to stocks, let's add $100. No more, yes, add to stocks, $100. No more, yes, to stocks, $100. No more, yes, stocks. Oops, I tried to type yes. No, yes. Stocks, $100. No, yes, stocks, $100. No more, yes. Stocks, $100. No more. Yes at 29. Stocks, $100. No more. Yes at age 30. We'll do stocks. We'll do $100. No more. And I'm just going to go no more. So if we did for 10 years, you put $100 in. So we put $1,000 in stocks eventually, right? Over 10 years. And we end up with 3 times as much. That's not too bad, right? It's not too shabby. So let's crank it up a little bit. Or maybe we should do individual values too, right? So value here. So we'll do mattress. Mattress, and that'll be our mattress money. Total value of banks, bonds, and stocks. Bank savings, bonds, and stocks. We're just having fun playing with it now, right? Seeing if it's going to work for us here. Oops, that was too much of a copy. There we go. All right, so we're going to print all those out. So let's do this one more time here. And now, again, $100 for an entire year is not all that much. If you can save $100 a month here, let's look at that. So we'll say, name's Eric. Let's say we start with nothing here. We start with nothing at age, or maybe 22, right? By the time you graduate from school. Yeah, it was supposed to ask for each year until they retire, ask if they want to add more money. The idea was we were working with our loops here. That's for each year until they retire. We're doing these things. All right, so at 22, say we've just graduated here, we want to retire at 70, and we have nothing right now. So let's put $1,000 in stocks every year. So that's a little less than $100 a month, right? So no more. We'll say yes. We'll do stocks for $1,000. Say no more at age 23. At age 24, yes. We'll put some money in stocks. We'll put $1,000 in. Say no more at age 25. Yes. We'll put some money in stocks. Put $1,000 in. We'll say no more at 25. Yes at 26. We'll put money in stocks. We'll put $1,000 in stocks. No more at 26. Yes at 27. We'll put money in stocks. $1,000 in stocks. No more at 27. Yes at 28. Put stocks. $1,000 in stocks. No more at 28. Yes at 29. Put money in stocks. Put $1,000 in stocks. No more at 29. Yes at 30. Put money in stocks. $1,000 in stocks. No more. Age 30. We'll do it one more time here. Yes, one more time. Put money in stocks. Put $1,000 in stocks. No more. So for 10 years, right, from 22 to 31, if you put $1,000 into stocks every year, and then nothing after that, boom, 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 right, and we get to age 70. We put $10,000 in, right? We end with about $26,000 after putting $10,000 in, right? Not too shabby. And again, this the randomness of this is a little bit funky, the way this is averaging out, because sometimes it goes down, sometimes it goes up. But that's not too bad, right? 26,000 in. So from 10,000, 2.6 times as much. Not too shabby. Right, so just a fun little simulator here. Again, our random, it's not even an exact random value, so the way it skews here is probably a little funny. Maybe we should have gone up to like 25% or something. Some years are even better. So, but that's sort of the idea here. All right, you okay so far? Does this make sense for project 2? To complete. We just finished out the stubs. And again, you didn't have to do it with functions. No big deal. But if you follow the sort of stub that we wrote out, right, we did our functional decomposition. We took a big problem, made it smaller and smaller and smaller and smaller to solve lots of small problems. It worked out relatively nicely, I think. Right? Just had to add a couple things here to our loop, but most of what's happening is all in the functions, which is pretty cool. All right, you okay? Any other questions, thoughts, concerns? I felt all right? Cool. So we'll come back to strings. So we got one last section here in strings. We can call strings good. So one of the most common things, and I'm going to do it up at the top here real quick, is having people enter a bunch of values. It's really nice if they don't have to hit enter every time, if they can just give you a bunch of values in a single line here. So we can have values be input here, and we want to say, we'll say enter your numbers separated by a space. So numbers separated by a space here. Then what we can do is I can get a list out here. So this is my values list. I can say values.split. So split then will take a string and split it on whatever character we want to. So if I want to separate on spaces, we can say split on the space character. That's actually the default. So just split here defaults to splitting on spaces. So if you want to do like comma separated values, you can put a comma in here. If you want to do other things, you can do other things in there. The book will take you through some examples like with slashes and stuff, or like the @ sign. If you want to separate someone's email address from the name and the domain, you can do that sort of thing here. Then we can print the values, right? Our values list here, sorry. So get some input. I can just give them a bunch of numbers here, like 1, 2, 3, 5, or I don't know, just entering a bunch of numbers. And then we get out the list of values here. Now there's still a string, right? So if I wanted them as integers, we have to do a little bit of extra work here. Now it's a little funny. There's some enhanced notation you can do. So our values list, if we want them as integers, we can say, oh goodness, we do For value in here, we want int of value. Right? Is that it? Value. No, we want int of value. There we go. We want all of that in a list. This notation is nuts here. I'm sorry. So we're using this for loop here, and we're saying, okay, for every value in values, do the thing here on the left, which is take it as an integer, and then we put it in list notation to say I want it as a list. So now we're getting out 1, 2, 3, 4, 5, the actual numeric values instead of the string values. So it's that's like the shorthand notation to saying here I want a numbers list equals a list, and then for value in values.split, I can take my numbers list, append int of the value. So this is the list or the loop way. This is the shorthand notation. They call this a list expression. I think that's our term for it, or list comprehension. That's what it is, list comprehension. Comprehension shortcut. People love this in Python, so you're going to get used to seeing it all the time. Just remember, it's doing this exact same thing. We're just saying, hey, do this, right? Do the thing on the left for every value in the things that you split, and then throw it in a list because we're using this list notation. Right? We can print our numbers list. They're the same values in it. Right? Both will do the same thing for you. One is just shorter. 4, 5, sure. We get 2 lists all with the same things. Right? And actually, I gotta go open up our Zybook. Let me make sure I'm covering all that real quick. String that's splitting. Now the opposite of splitting then is joining. So you can go from a list then and put it into a single string with a join. So this was split, where we take one string, turn it into a list. Join will turn a list into a single string. So if you have, then we'll say, maybe we can even use our numbers list here. So if we wanted to print out those numbers a little bit prettier here, we could take a pretty single string is going to be our list here. So our values list dot join. And with join, you say, well, what character do you want to put in between them here? So if I want to separate them with spaces, or maybe even like a comma here to comma separate them all, it's going to take every value and put a in between them. In between them. Is in between a single word? Is that 2 words? I really don't actually know. Then we can print out our pretty single string. Oh, goodness. Because... What do you mean list has no object to join? Oh, goodness. Oh, that's right. Okay, I'm backwards here. So it is opposite. So it's not the list join, it's a string dot join given the list. Sorry. So it's a string operation. So here's the string that I'm going to use to join these values together. Sorry, I had that backwards. So I always have to look it up. Expected a string, int found. Okay. So if our list here is strings, or is integers, we can't join them because join works with strings. So we need, for value in values list, we want the string of the value here. See if that works for us. There we go. Okay, so this will convert them, every value as a string here, joined back. Goodness, that's ugly. Sorry, friends. So it's a join. So it's the opposite of split. So you can split and then you can join, put things back together, take them apart any way that you want with strings. So the character you want to join on for the things you want to join. People love doing, again, this list comprehension stuff all the time. I think we'll look more at that actually next chapter, but this is fun working with strings and splitting values back out. So if we were to ask people to enter a bunch of values, right, we could ask them to enter in a single line, and then we could split it up ourselves to turn it into a list. Just a shortcut for us, rather than having to prompt every single time, which is pretty cool. Gives us some options. Okay, so that's about all the fun stuff with strings we're going to do. Again, take a look at the Zybook, go through some of their practice stuff, and then you'll be sick of strings by then, and we can go from there. Looks like we're still a little behind on Zybook's participation and things. Oh, why? It's a zeros. Hang on. I think someone screwed up. It should be a bunch of zeros. I think that's got to be wrong. We commit this here, so some more strings. So string, split, and join. Commit and push. My computer's just being slow. It knows it's almost done for the day. Happy Thursday. Yeah, Zybook isn't even loading any of that. That's a bummer. I got like nothing. Yeah, definitely get caught back on. Oh, there we go. Okay. Yeah, it looks like 8% of the Lab stuff has been done in functions, only 22% of the functions, and then again that's of the class, so like 22% of people might have done all of it, or like 10% of people might have done half of it. It's hard to tell. I can look deeper at the numbers later, but do make sure you're keeping up, please. You don't want to leave it to the end, because it'll just take you more and more and more time. Those add up, but honestly the only way to get better at programming is to practice, and the more practice you do, the better you're going to get at it. So practice our labs every week, practice the Zylab stuff, do the projects, and you'll start picking it up for sure. Right, so if you don't have any other questions, thoughts, or concerns, we'll call it a day. Again, there's no need to show up to lab in person. You're welcome to take that midterm anytime you want. I'll open it up in the morning. It'll be due by midnight, but once you hit start, you have that 2-hour window in which to do it in. So whatever 2-hour window you prefer, go ahead and take it at that time. We should be in good shape, okay? All right, let me call this ending here. And I'm not sure there's actually anyone around. We keep rating the same people over and over and over because that's just how our timing works out. So I don't think there's anyone around that'd be interesting for us to rate at the moment. Well, we can just end it and have a good day. All right, if you got any questions, let me know. Reach out, call, text, email. We can go find me on Discord. We can go from there. Thanks, everybody.